Okay, the last example. Same frequency, same speed of sound and air, basic equation. The observer's in blue, the source is in green. They're going in the same direction at different speeds. If they were going in the same direction at the same speed, you'd hear the actual frequency. But they're not. They're going in the same direction at different speeds, all right? 30 versus 20, there's a 10 meter per second difference. So for the first part, the observer is behind the source, all right? Now, we're going to do the same thing as we did in question 3. When to analyze the numerator, it's all about the observer. When an observer can pretend like the source isn't moving for a second, because we're just looking at the observer, and that arrow is towards the green source. And when an observer goes towards the source, you always add. It leads to a higher pitch. Always. So I'm going to add that. Now let's look at what the source is doing. The source is going that direction. It's in front of the observer and it's going that direction. All right? Pretend for a second that the observer is not moving, just for a second. That source is going that way. That leads to a lower pitch. When a source is getting further away from you, all right, in and of itself, this is just, you just break it up. Looking at the denominator, the source's motion in and of itself is away from you. That leads to a lower pitch. So I'm going to, how do I make the pitch lower? I make the denominator bigger, all right? Notice that when they're in the same direction, they have the same sign in the numerator and denominator. Okay, so now let's put in the numbers. 440 for the actual frequency. 345 plus 30. 345 plus 20. So 440 times, what's that? 375 all over 365. By the way, I would expect in this particular example for the pitch to go up because that's faster than that. They're getting closer together as time goes on. And that's what we're going to get. It's not going to be a big difference, but it'll be a little higher than 440. And the answer is 452. 452 hertz. Now, you notice this is going faster, so it's going to overtake the source. And once it overtakes it, the exact opposite is going to occur. All the numbers stay in the same positions. It's just that we're going to do the opposites here. All right? You know you're going to hear a lower pitch. You're the observer. You're going to hear a lower pitch. Why? Because that's only going, the sound source is only going 20. You're going 30. You're going to get further away. Okay? Now, let's do the same thing. In the numerator, it's about the observer. The observer is going away from the sound source. That leads to a lower pitch. Subtract. Now, talk about the denominator, the source. The source, in and of itself, is going towards that observer. Whenever a source goes towards an observer, you hear a higher pitch. So you would, to make the pitch higher, you make the denominator smaller. Counterintuitive. Now let's put these in here. So that's going to be 440 times 315 all over. Is that right? Yeah, all over 325. And that is 426. Is that right? Yeah, 426 hertz. Okay, we did that right? Yeah. And we're done. Yay!